Welcome back, everyone. I hope you are well rested and prepared for another day of the ROS Industrial Conference. In this session, Robots and ROS Industrial, we will hear presentations from Werner Kraus, Head of Robotics at Fraunhofer IPA, and after that from Eric Unimeyer from ARTC, who is actually the manager of the ROS Industrial Consortium Asia. Werner Kraus will now give us some details on Fraunhofer IPA and the uptake of robotics in general. So Werner, you can also switch on your camera, superb. And the floor is up to you.
Thank you, Christoph, for the introduction. Hello, everyone. Good morning from Stuttgart. It's a pleasure today to talk about the current market situation in robotics. We just in October released the International Federation of Robotics Robotics Report 2020, and I will give you some insights during my talk. My name is Werner Kraus. I'm head of the department Robot and Assistive Systems, and we are sitting at Fraunhofer IPA in Stuttgart. So Fraunhofer itself is the largest research organization for applied research in Europe. We have around 28,000 researchers, mostly located in Germany. Fraunhofer IPA is the third largest institute within the Fraunhofer Society. We have around 1,000 employees, a budget of 76 million euro. In robotics and automation, we have around 10 to 15 startups in operation. So this is also one way of our technology transfer. The other way is industrial projects. We are performing around 1,000 projects each year with industrial customers, which gives us a revenue of 29 billion euro. Good. Our organization, so Fraunhofer IPA was founded in 1959. We started in robotics in early 70s. Actually, we were the first one working with robots in research in Europe. And we are a one-stop shop about production technology, automation, and you see here our field of actions, manufacturing, process engineering, network production systems, of course, resource efficient production, which is really became more and more important with the Green Deal of European Commission, about surface technologies. We are also doing medical engineering and biotechnology. And our robotics division is intelligent automation and clean manufacturing. So in our department, we have 70 researchers. In robotics itself, we have around 150 full-time researchers working in all kinds of robotics. Our robotics department is busy in 7 groups. So we are doing handling, intralogistics, which is focusing on pin picking since 20 years, welding and machining for SMEs, assembly automation. You know the video from the video competition of a dual arm robot for automated wiring. Then also lots of planning and development of robot systems. In the area of service robotics, we are focusing on navigation of autonomous mobile robots in the group of professional service robots. Then we have the long history of the care robot in the group of household and assistive robotics. Of course, then software engineering and systems integration, which is responsible for ROS Industrial. And we have a modular system for service robot technologies, which focuses on perception, grasp planning, navigation, action recognition, and so on. To give you a vision of our industrial robotics activities, we say automation of automation. In the last years, the efforts for integration and reconfiguration rise exponentially due to the individualization of products as a megatrend of our society and production industry 4.0. And till today, we have a robot investment only of 25 to 30% of a robot system. Around 40% of the investment in the robot systems are personal costs. And despite robot became more and more cheaper, these scale effects are compensated by the individualization of the production system. So furthermore, this automation is often introduced into brownfield applications, so into areas which are performed for designed for humans, not for robots actually, which again contributes to integration efforts. And also when it comes to reconfiguration, experts are needed to change the production system. And it was is the motivation to talk about automation of automation, to say, okay, we have the automation system understood quite well, but all the tasks around the automation system are subject to be automated to lower integration and reconfiguration efforts. To give some examples, it's about production control utilization, optimized matrix production, for example, which is used in semiconductor industries. When it comes then to the design of assembly lines, where we involve robots, human-robot collaboration, manual workstations, we are working on automated layout generation, which uses models of robots with their reach, with their speed, to automatically generate designs for assembly line. Another topic is automated risk assessment, where we are relying on offline programming and simulation, which combined with models about human behavior, models about safety technology. And you see it in the picture that there are yellow boxes, and these boxes represent if where the human can reach. And this allows us to dramatically speed up in the preparation time of new automation system. When we are talking about service robots, they are the backbone for automated material flow with autonomous mobile robots. So matrix production, for example, relies on AMRs. And we will see it later in the statistics. Last year, the AMR market increased by 110%. Then we have topics about singularization of objects, bin picking, where we are using machine learning to faster learn new workpieces without expert knowledge, and in the end, then also self-optimization of process parameter. So we can see it's a lot of simulation and software stuff going around to, in the end, lower the integration efforts for new robot systems. Now I jump into our IFR statistics. When we are looking into the application fields of industrial robotics in 2019, the picture is almost like in the last years. So almost 50% of the robots are performing handling tasks. So pick and place, sorting, palletizing, depalletizing, and this is all are always stationary robots. So typical industrial robots. Then around 10% of the robots are working in clean room environment. 20% is welding. Assembly is again 10%, so quite poor actually. There's a lot high potential to be automated in the future. And the niches, machining and dispensing. So that is as usual, I would say. When we are looking to the sales numbers, we see that after the peak in 2018 with 411,000 newly installed robots, the economic slowdown impacts industrial robot sales. So last year, only 390,000 new industrial robots were installed worldwide. we have overall now operating stock of 2.7 million robots. In this 390,000 robots, this includes 18,000 cobots actually. So 4.7% of the industrial robots are cobots. I just heard yesterday that Universal Robot delivered the 50,000th Universal Robot, and this is one of the market champion in the field of cobots, which is also reflected in this study. Good. When we are looking into the robot density, which is the relation between number of robots to number of employees in automotive and non-automotive, we see increasing numbers. For example, Korea has now 2,500 robots per 10,000 employees, which is top one. Worldwide average density 113 robots. In Europe, we are in the in the middle, and China targets a density of 150 robots per 10,000 employees. And when we look to the right, to the left, we see that around 1/3 of all robots were shipped to China. So China is really the largest robot market, and this will, in the end, foster the China robot density. When we are looking into the financial view on robot industries, we have the industrial robotics and service robotics. In the industrial robotics market is $13.8 billion in 2019. So this turnover is performed by around 80 industrial robot manufacturers worldwide. Then we have on top the system integration, which is almost double the size of the robot market itself. So it's again $28 billion. So in the end, we talk about a market in the size of 40 to 50 billion of the total industrial robotics industries. Actually, the market grew quite well in the last years, around 11% annually. And also robots became much cheaper. For example, here from within 7 years, the price dropped from 53 kilo US dollar to 37 in 2019. When you're looking into the service robotics market, this market is even larger as the original industrial robotics market, 17 billion US dollar, where 11 billion US dollar are professional service robots, 5.7 in domestic personal ones. Meanwhile, we have almost 900 service robot suppliers identified, where 25% of them are startups. Around 70% are using ROS, and we see really strong growth rates in the service robotic market, around 26% in the professional area and 23% in the domestic area. So this is our application wall, part 1 for professional use. So evergreen applications are milking robots for agriculture. Lots of research is going on for the introduction of robots on the field. Then we have robots for cleaning, which is got a strong boost due to the disinfection robots. So we expect a strong growth in this area. And it shows that the service robotic market is really diverse. Looking to other applications, logistics is strongly growing in all areas, within warehouses, within manufacturing, also outdoor applications of robots for last mile delivery are rising. Then in the field of medical robotics, we expect also a dynamic in the market because the patents of the Da Vinci system are expired. So new market players enter the surgery market. Then exoskeletons become also more and more accepted by the workers. Telepresence is also one of the winner from the COVID-19 pandemic. And then we have some robots for guidance, which in the end lack the business model. So for our statistics, we have this workflow that the IFR contacts the service robot manufacturer and asks them for the current sales numbers, the expected sales numbers in the next years in the respective domains of applications. So today we have around 60 application areas. We are revising the structure these days to get it more condensed, to make it also easier for the companies to submit figures. And if you are a service robot manufacturer, we are really happy if you support our study by providing market figures, because this is the base for our statistic. Good. When we are looking into the main application areas, we see the mentioned strong growth rate. Actually, the medical robots market is the largest one from financial view, because the robots are really expensive. From the numbers of view, logistics robots are dramatically larger than medical robots. And we see here also the strong growth rate of from 0.9 to 1.9 billion US dollar from 18 to 19, which corresponds to a growth rate of 110%. Then we have defense applications. Field robots is quite stable. There's also one thing happening in the market, that robot as a service becomes an important business model. And we are asking also our companies about robot sales and also turnover with robot as a service, actually. And there are companies in the market which make 80% of the turnover with robot as a service. So this becomes more and more important, especially in the area of mobile robotics, where the integration costs are quite low and a high demand for flexibility exists. In the domestic application market, which is, for example, then vacuum cleaner for home, lawn mower, window cleaning, we have also strong growth in this market. And there's also a high demand from the market for more and more intelligent robots. Good. When we are putting this together, we can also look back to really a strong growth in both professional and domestic service robotic market. When we are looking on the right on the market structure, these actually in Europe, half of the manufacturers of service robot are located. Then in the United States, Russian Federation, and not that much actually in China. So in the end, we also see that the service robotic manufacturing is a startup business. So every fifth company is younger than 5 years. And in summary, we have 890 service robot manufacturers. Good. Looking into the business sizes, this also shows that service robotics is subject of smaller companies. You see it here, business size. So the most service robot manufacturers have less than 200 employees. So it's really always a company which targets a niche, develops a system which solves specific tasks of the customers. And this is really special in service robotics. Good. To my my last slide for today. We see that with ROS, lots of new robot applications come into the market, and we have the EU Robotics Technology Transfer Award again open. It's the 17th edition, and we are looking for applications from teams from industry and academia which successfully transferred research results into products. So, for example, last year the UVD robot from Blue Ocean Robotics was our winner, and participation in the award gives you visibility in the European robotic community. So you see here the picture of the award ceremony. Next year, the award ceremony will be during the virtual European Robotics Forum, which will take place in the second half of April. And I'm looking forward to receive your applications until 29th January. And it would be a pleasure to have applications from the ROS Industrial Consortium. Good, then thank you for your interest, and I'm happy hearing your questions.
Thank you very much, Werner, for this short overview over the robotics sector. I think, well, we can ask one question right now, and then let's go on to the panel session. So essentially, Werner, how can ROS actually help simplifying system integration? So you showed that the system integration market is actually even bigger than the robot market itself. So I think probably there's the biggest potential of improvements, most probably.
Yes, definitely. That's the one point, right? The integration market is double the robot market. The other point is when we are looking into the company sizes, we have small companies in the market which have not the power to develop everything from ground. And definitely ROS helps to get earlier in the market. And that's also the thing what we are observing in our own startups, that with small development teams of 10 people, they are able to bring a good product on the market with a combination of closed source and open source. I think the other point is also ROS for prototyping, to make really first proof of concept, to get a really fast proof of concept. And so ROS is for me something like a 3D printer. So this is the first niche of ROS that we get really first quite fast to results.
All right. Well, we still have a little bit of time, so we can ask another question that just came. Werner, what do you think about the future? And there specifically, are you not concerned that we are going to not have enough robots or robotics professionals in the near future to, let's say, cover the need?
Mm. Yes, actually, this is one of the concerns of the robot suppliers, that there are not enough, for example, also system integrators, which in the end turns out to be the bottleneck for especially when entering new markets, which was already the case in China, which has not this ecosystem of system integrators. This is this in the end motivates this automation of automation to lower the expert involved in the deployment of robots, and in the end it will be the solution easy to use, that more and more off-the-shelf robot applications can be commissioned by the end user.
All right, thank you, Werner. Thank you very much for this answer and for the presentation. I think the next questions we'll take in the panel session directly after Eric's presentation. So thank you very much, Werner, for your presentation. And let's start into the next presentation, which is coming from Asia. And we're really happy to welcome Eric Unemeyer here, who's actually the head of the or the manager of the Asian branch of the ROS Industrial Consortium. And he will present to us some updates from Asia around ROS Industrial. So Eric, thank you very much for being here, and it's the floor is yours.
Thank you very much. Okay, I believe you're able to see the screen here at this point. So good morning, everyone, and thank you for joining this session today, which will cover updates from the Asia-Pacific side of the ROS Industrial Consortium. ROS Industrial Consortium Asia-Pacific is operated by the Singapore Agency for Science, Technology and Research, Advanced Remanufacturing and Technology Center, from where I operate as well, and our team here with ROS Industrial Asia-Pacific. For those of you who are not previously familiar with us, we're a leading public-private partnership research institute for advanced remanufacturing and manufacturing technologies here in the Asia-Pacific region. We work very closely with our industry partners to develop new technologies for industry adoption, which includes robotics, which is one of our main technology pillars of our center, which is also why we have a significant interest in ROS and open source robotics as well. ARTC is heavily focused on applied research or adaptation of technologies that can be directly leveraged into industry, as well as bridging the so-called valley of death or technology readiness levels 4 to 7, if you're familiar with the TRL levels. So this is a common challenge to bridge and move forward early research activities into something that has the process capability, performance, and robustness to operate successfully in production or industrial settings. So with that, I'll share a bit more about some of the ROS-based activities that we have been focusing on here throughout the year. I'll share in a little while a bit more about some of the technology developments and consortium activities that we have been engaged with. But I'll start off a little bit quickly today here first to talk about some of our efforts related to enabling easier and more consistent industry-grade quality for ROS-based components. The global ROS community has been actively engaged in deriving what is known as the ROS Enhancement Proposal 2004 this year, or REP 2004 for short, which is an effort to derive a set of quality process and metrics for ROS packages. And this is really beneficial both for package maintainers as well as users that are looking at adopting these technology packages, as it provides more coherent guidelines and makes it easier to both improve on and also assess the quality of a given package compared to the ROS platform overall. Many of the categories in REP 2004 that has been defined are quite process-oriented. These can include things such as versioning policies, change control process, and so on. Traditionally, one of the very time-consuming steps, of course, related to ensuring quality is the one of actually performing testing and validation itself. And one of the questions that we asked ourselves is, could we fully automate REP 2004 testing criteria to allow the current state of a package to automatically report the quality level according to these new guidelines? So in order for us to make it easier for ROS package maintainers to keep track and adhere to the quality standards in REP 2004, and for adopters to understand the current state of test quality in a package, we're proposing to add standardized acceptance criteria in addition to the process requirements defined in REP 2004. This would allow the continuous integration pipeline to automatically determine the quality level based on the output results and metrics that have been defined. So in turn, this will actually enable us to provide a more coherent and automated assessment method to determine the REP 2004 quality level for different code base over time. So in summary, in our journey towards automated industry-grade quality, which is a goal that the ROS Industrial Consortium globally, we're sharing within our 3 regions, both the contributions by Fraunhofer Institute, Southwest Research Institute, as well as ARTC. We see that the effort by the community to derive a standardized set of process expectations for quality is a great foundation for harmonizing quality of ROS software, and in particular our new ROS-II platform that more and more people are switching over to. And by coupling this together with automation testing as well as standardized criteria, we'll provide industrial organizations with greater transparency and more informed decisions when adopting ROS-based packages for production and deployment. ROS Industrial will continue to enhance the industrial CI package for improved automation test capabilities and engage with the community to provide transparent software quality for ROS. Industrial CI is a package that has been contributed by and is actively supported by the ROS Industrial Consortium globally, and will continue to maintain this over time for the benefit of both the community as well as industrial organizations. So with that, I'll move on to updates on ROS-II technology development activities that we have been working on within our team here at ARTC, as well as with some of our collaboration partners that they have related to ROS-II development. ARTC and the ROS Industrial team is currently leading a ROS-II development program together with our collaborators, the A-STAR Institute for Infocom Research, as well as Open Robotics, as well as private collaborators sponsored by the Singapore National Robotics Program. The key driver for this program is really to accelerate adoption of robotics through the means of open source ROS. And in order to be able to do that, a few of the key focus areas for this program is to ensuring that the packages, technologies developed are following formally tested formal validation and test processes. And the second main goal is to ensure that some of these new ROS-II based technologies and packages are easy to set up and deploy, yet flexible enough to provide additional customization and to continue evolving as new state-of-the-art algorithms and technologies are introduced over time. There are 4 main technology areas that we are focusing on as part of this program, and today I will share more details specifically about our ongoing efforts related to perception and manipulation in ROS-II. So the main emphasis on the perception and manipulation efforts are catering for primarily for smaller businesses to lower the technology barrier for them to adopt robotics technologies for various process applications. So in the spirit of providing industry quality ROS-II components that are easy to deploy, the package Easy Perception Deployment provides robotic vision capabilities that can leverage state-of-the-art machine learning models. So this package provides ready capabilities to perform object segmentation, localization, measurement, and tracking, and comes with a user interface that makes it very fast to train and deploy, even if you're not an expert in machine learning frameworks or up to speed on what is the latest algorithm and to use. It also leverages the open standard ONNX format for deployment of machine learning models. So it will be straightforward for users that would like to import other models or plug in new high-performing models over time as they become available, rather than fixing the package to only work with a specific model which would require a bit more replumbing and customization to import other models in the future. So here's a quick example of what the package looks like in action, performing object segmentation, as well as determining the main axis of the object, which may be useful for grasping. A performance benchmark on our reference system shows similar performance in terms of speed as compared to YOLAC ROS, but a slightly higher accuracy score for this specific model use. But I think the key thing to note here is not specifically the performance of this particular model, but rather that the package is really intended to be easily upgraded to other algorithms, and also maintaining and providing a standardized API set to perform robotic tasks such as grasping using its output. So there's very flexible, customizable, and will be easy to maintain going forward as well. Okay, so here's a quick demonstration of how this package looks like in action. So this is easy perception deployment plugged into a pure ROS-II based system to perform conveyor belt picking, where we have a native or a very lean ROS-II driver driving a Delta robot to work in conjunction with the easy perception deployment package as well. I'll share a bit more about our beta releases of the package that is currently available, as well as our planned upcoming releases and features. Beta version was open sourced in September. That included the user interface for configuration and training, ONNX support, and object detection and segmentation. We have just added additional feature support on top of that to perform automatic object measurement, rotation, and localization that is suitable for grasping related tasks. By the middle of next year, we're planning for a formally validated drop that includes object tracking capabilities, as well as robust and optimized performance for the full pipeline, which will be our first production release of this package. Easy perception deployment is available in our ROS Industrial GitHub, and you may access it directly through the links provided here in this slide. It can also be leveraged directly for commercial applications, of course, based on its business-friendly Apache license, which is commonly adopted for ROS platform components and packages as well, which we're following. The second ROS-II package I will share with you today is called Easy Manipulation Deployment and provide fast grasp planning capabilities, and is intended to flexibly support a range of different types of grippers. This package provides three main capabilities. First, it provides a Workcell builder user interface that makes it quick and intuitive to create a Workcell representation. Secondly, it provides a grasp planner with a key design intent to be a fast planner that can determine a suitable grasp location flexibly for a range of different end effector hardware architectures, which I'll talk more about in a second. Finally, it leverages robust and dynamic path planning and execution using existing ROS packages such as MoveIt that is well established in this area. So one of our key design goals for this package is to make sure that it's a solution that is easy to set up and configure. So for the Workcell builder, it provides an intuitive GUI to define and modify your Workcell and robotic subsystems within the environment. We conducted a usability test benchmark and measured the time required for an experienced ROS user to set up a reference Workcell accordingly, either using a traditional manual approach or using the Workcell builder. The time saving was quite significant, from almost 20 minutes for an experienced user down to 1.5 minutes, and we anticipate that the overall time saving for a new ROS user to use the Workcell builder would be significantly higher as well, given the learning curve required to do it manually the first time you're using ROS. A second key design goal was that we also wanted this solution to be able to very flexibly and out of the box support a wide range of gripper models, including grippers of different hardware architectural design. So in order to achieve this, we decided to embark on an algorithmic approach for grasp planning instead of using a machine learning based approach, as this would typically require new training and annotation of the training data set to enable a new gripper to be used, which can be quite time consuming. The algorithmic approach enables us to parameterize the gripper characteristics and provide a more generic solution for calculating valid grasp poses. It also provides us with quite a bit of control over how we would like to optimize the computational pipeline and how we would like to trade our speed versus peak performance for boundary conditions, for example. Here's an example of how the parameterization of the gripper characteristics looks like for one type of gripper architecture in the form of the configuration file used by the grasp planning system, used as input for the control library execution. So this configuration file provides a very simple and flexible way to input end effector attributes in a human readable format and allow the planning library to cater for these variations of hardware characteristics more flexibly in the library itself. The current implementation of the grasp planner uses a simple rectangle to represent a two-finger gripper, but expanding on this capability, it's possible to represent more complex gripper architectures such as three or four finger gripper types of different architectural types while using the same grasp planning methodology, as combinations of this basic grasp representation can be combined in various forms. Similarly, the second main set of commonly used industrial end effectors that we wanted to support is various types of vacuum end effectors. So in a similar approach as the finger-based architecture, the grasp planning library would support combinations of a basic representation of a single suction cup to represent these various types of commonly or customized, for that matter, suction cup arrays of various forms. We've conducted some early sanity testing on grasp planning capabilities using a reference two-finger gripper configuration for a set of objects with a variation in size, height, and shape with successful results so far. And we will be conducting more extensive testing and expanding on these test scenarios also for other gripper combinations in the first half of 2021. The main emphasis on the solution overall is to cater more for the 80-20 use cases, where we can make it really easy for users to adopt this package for more commonly used industrial end effectors and successfully use it with high reliability and performance for objects with some variation in shape and size, but not too exotic such as very well-known, extremely problematic objects, or for example, objects that has a very complex weight distribution that may impact the grasp, reflectivity, or transparency, or other types of attributes that makes it very challenging for a grasp to be successfully applied. Although this package is still in alpha stage, early limited performance tests the team has conducted on a single CPU core with without GPU acceleration shows that grasp planning times are already relatively fast for a two-finger gripper configuration, while we still have a fair amount of opportunity to further conduct performance optimization at a later stage in development of this package. And in addition, as mentioned, easy manipulation package does not require training, so it can flexibly support different physical constraints and parameterization of your gripper configuration out of the box. To illustrate one example of how ESA manipulation deployment with some customization could be used for more complex setups than just a single gripper configuration. With fast computation of suitable grasps for more than one gripper type, multiple grippers could be deployed to a single robot to create a low-cost picking system that is able to serve high-mix applications more easily at lower cost. So we are currently publishing the first alpha release of ESA manipulation deployment that will be available within the next week or so by the end of this year. This alpha release will include the Workcell builder user interface, as well as the manipulation pipeline with support for two-finger gripper, as well as single suction cup gripper architectures. By the middle of next year, we're planning for a full formal release that has wider support for various industrial grippers, collision avoidance, as well as further robustness and performance optimization of the package as well. So the alpha version of ESA manipulation deployment will be made available in our ROS Industrial GitHub as well. And if you're interested in testing this package or have a specific or interesting use case for this that you want to explore, feel free to reach out to us, and we're happy to share more details about some of the current capabilities or also limitations and constraints given the current state of the alpha release package that we have available. So with that, I'll move over to some quick updates on the ROS Industrial Consortium activities that we have here within the Asia Pacific region. Of course, as part of the consortium activities, we perform a wide range of different types of outreach activities, promoting ROS-based technologies, sharing information about ROS to industrial companies on how it can be adopted, as well as providing regular training sessions for ROS for industrial applications. In addition to these activities that we regularly conduct as part of the consortium operations, I'm also delighted to announce 5 new consortium members that have joined us here in ROS Industrial Asia Pacific this year. We have companies like Cognicept, Delta Electronics, Johnson & Johnson, Schaeffler, as well as TDS Technology joining our membership base for this year. And they join our global network of over 80 members supporting the advancement of ROS for industry within our global consortium. As a member of the ROS industrial ecosystem, technology and solution providers, end users, and research institutes come together to advance development of new ROS capabilities for the industry, tap on ROS expertise to scale up the robotics faster, and to co-innovate and contribute back to our global community. This concludes my sharing for today. From the ROS Industrial Asia Pacific team and ERTC, we thank you for you and your organization's interest in ROS and open source robotics, and as well as any contributions that you may have made to the community as well, if you're already an active ROS developer and contributor today. Thank you very much.
Thank you, Eric, for your presentation. That was really great news from Asia Pacific. A lot of new packages coming up, so that's great. So I would now ask all the speakers to switch on their camera in the session so that we can have our panel. Eric, we have, I would first start off with some specific questions to your presentation. So essentially, one question that was coming up here was essentially, in terms of your manipulation package, have you considered contacting the ROS and Effector project, or have you heard of it, let's say?
Yes, yeah. So I think that's a very good question, and in fact, there's have actually been some engagement and discussion between the ROS-I project as well as this project as well. I believe there's actually a lot of potential synergies to not necessarily combine these two projects, but rather I think they're actually quite complementary to some regards. From the ROS Industrial Consortium perspective, one of the missions that we have as the ROS Industrial Consortium is also to look at standardization. So if you look at standardization of MoveIt, we have MoveIt as a very, very well-established package, and we have some standardization on drivers for robots. So I think the next step and the logical effort that we should look at, which we do have interest in from the consortium side, is to look at how we can over time also standardize end effector communication and interfaces as well. We are familiar with this with the ROS end effector project, which we think is a very good project and very interesting project as well. We see that there's potential synergies for these two efforts to be I don't think they're necessarily overlapping, but rather I think there's potential to look at some of the pieces of these two respective projects that can actually complement each other. So that's we actually already have some communication between the different project teams and within the ROS Industrial Consortium to look at how do we take that forward. If you look at ROS Industrial from a consortium perspective, one of our mission is also to look at standardization. So for example, for multi-axis robot control, I think if you look at packages like MoveIt, there's a fair amount of standardization already available for communicating with robots today. And I think a logical next step is to look at how we can standardize some of the interaction with end effectors, whether they are more simple end effectors, such as the more industrial type end effectors that we are primarily looking at in this project, all the way to eventually looking at more complex end effectors and also end effectors that are augmenting with the sensor input as well. So for this current project that we are primarily looking at vision-based grasping. We're not looking at a sensor, closed loop kind of sensor input for this particular project. But if you look at standardization of end effectors, the long-term, mid to long-term initiative, that's something that I think we have a lot of opportunities to see how we can standardize this. And I do think that the ROS Industrial Consortium potentially have a role to play in this area. So we do see the ROS end effector project to be a very interesting project. We are quite interested to see how we can synergize on that going forward.
All right. Thanks, Eric. There have been two more questions, mainly related to your presentation of the perception package. On the one side, there's a question about who do you think are the users of these of the perception package? Are you targeting system integrators or manufacturers directly?
No, in this case, we are targeting smaller system integrators. Like I mentioned, one of the key goals of this particular program is to see how we can lower the technology barrier to help increase the adoption of robotics by providing kind of simple solutions that fit maybe 80-20 of some of the use cases. So we're looking more at some of the more basic use cases, not necessarily looking at covering every type of possible more advanced perception capability. So we're looking more at how we can make that really easy to set up, install, and then actually make it work in conjunction with this manipulation package that we have. So these two packages actually work hand in hand in this case, where we are looking at providing a kind of like a reference, an open source reference system that can be very easily adopted to create some simple types of picking applications to help smaller companies adopt robotics. So that's kind of the more holistic goal of this package, which is also driving some of these design decisions that we have.
All right. And another question was, is there already documentation out there for the packages that you presented, or is that part of the next release?
There is actually documentation for both of these two packages available. However, if you see if you are keen to start using the package and you see some potential gaps, feel free to contact us, and I think we're happy to help improve on the documentation. We will be providing formal documentation as part of the effort as well, and there is documentation, some tutorials on how to start using the package. So hopefully it should be sufficient to get started for now.
All right, and people have been quite stoked with your usage of a Delta robot. And they were asking if there's a driver for this robot available in ROS.
So this particular driver we have not actually open sourced at this point, but it's like I mentioned, it's a very lean driver, so it's actually quite a simplistic driver, not really like it's not actually a full driver to have integration with Move It and so on. So it's a very simple driver just to send motion blink commands to this ABB driver. If you have interest in some of these drivers, feel free to reload your driver.
All right, I think you were breaking up in the last part, but I think what you were mentioning is that you're happy to help, right, Eric?
Yes, feel free to apologize that the connection is so poor here, but feel free to drop me an email if you have queries on this. But it's a very simple ROS2 wrapper around sending commands to the robot. So it's not a full Move It driver, for example, today. Just to be clear. Yeah.
All right, great. Now the connection is good again. All right, we have one more general question that I would like to open to both of the speakers here. So we had the discussion, I think Werner mentioned it in his presentation, that ROS is very good for use with prototyping. And now we have the question, why only prototyping and why not for the final product? Maybe Werner, you can have a short statement on that.
Yeah, I expected to have a discussion on this point. I think it's the prototyping area is like a beachhead in the automation industry, because there ROS makes fully sense, and starting from this beachhead, ROS moves on into also productive applications, because people see that it works, that we can trust ROS. And I guess that's a good strategy to enter the complete robot software market. And it's somehow the same way like Salesforce did it, that they first targeted, they wanted to provide software as a service, and they targeted on the niche of salespersons and their managers. It worked in this small niche, and in the end also marketing guys wanted to have it, CEOs wanted to have it. And that's I think the way we are moving on, and we have done this mouth-to-mouth propaganda talking about ROS.
Yeah, I think also here from Fraunhofer IPA, we have some experiencing with, or let's say advanced experience with putting ROS into products. So this is really something that you can do today. So we have found that, or actually I think now it's 3 startups that are founded or in the pipeline of being founded quite successfully with products really based on ROS. And as I presented yesterday in the morning, we've also collaborated already with many companies to put ROS into their products. So I mean, ROS comes from development, but today I think we can find a lot of solutions already there on the market where ROS is really used in products. So nothing keeps us from using in ROS in products. Eric, do you have also a statement where maybe with an Asia Pacific view on these things?
Yeah, I do see that we see a lot of interest in ROS, and in particular ROS2 also for production use cases. So I think that's definitely where we see more and more interest, and people actually want to adopt ROS for industrial, production related use cases. I think with some of the quality enhancing measures and the ROS2 platform, I think that enables some of this, but I think going forward, other aspects of operationalizing ROS-based use, you have other things that you have to bear in mind, such as security. Not talking about DDS and secure communication, but rather, cybersecurity from a whole product perspective, You have things like the formal validation, certification, and other aspects. So I think the sort of thesis that I think ROS Industrial, other industrial companies that are also supporting ROS-based effort, we have a lot of opportunities to contribute in those fields, and I think that we are moving in that direction. And I think we also see that the interest is definitely picking up. So, for example, today we have a number of projects actively ongoing together with the industry, where the end final deliverable will actually be in a production setting using a ROS-based system.
Thanks, Eric, for this statement. I would have another question that we might discuss, especially what are your estimations which application areas will grow the most in the next years, Werner?
I expect, definitely logistics market with AMRs as well will have much more growth. We expect also in the domestic market large growth due to lockdowns, that are people focused on a better housekeeping, also gardening robots, pool cleaning, and so on. But definitely in the professional, it's definitely logistics, and we see that also cleaning robots are at a tipping point, that they become technology mature and interesting from economic point to be widely adopted. So, for example, also large supermarket groups are investigating rollouts in all their markets of professional cleaning robots.
All right. Yeah. So we actually asked this question more or less also to the audience. So the audience is also quite suspiciously. I'm not saying suspiciously, but essentially the numbers are match up more or less. So everyone says, okay, we have warehouse, industry, and agriculture as big application sectors, and probably in the next 5 years that will stay like that. And then we have a little bit smaller, like professional cleaning and domestic robots. I think very interesting. So I think actually most of the application areas here are most probably some future fields, and we will probably see even more of those. Eric, do you what is the situation in Asia and Pacific? Do you see do you see other applications becoming more important in Asia than we maybe see in Europe?
I think it's probably general trend. Of course, if you take more local efforts, because we're based in Singapore, which is more of a city state, of course, there's some of those larger fields such as agriculture, where maybe we don't have the same demand as you may have in the US, Europe, or maybe the greater Asia Pacific region. But I think we also see trends coming up in areas where you have maybe dangerous work or more laborious efforts, can be areas such as construction. I think also surveillance is an area where I think, at least in Asia, I think surveillance is quite a broad area in many countries in Asia as well.
All right, thanks, Eric, for this comment. I think we can all agree that robotics has a bright future ahead. And one question here that I would also ask is, what role will ROS play, in your opinion, in this future of robotics? Maybe we can directly jump again to Eric.
I think at least for me, from ROS Industrial Consortium perspective, I think one of the areas here is really about the standardization and the standardized building blocks, the standardized environments to create things much faster. I think that's really the hardware. I mean, the power of ROS to provide hardware agnostic interfaces, connectivity, provide software control libraries and capabilities that can actually be plugged in, customized, and so I think that's really where I do see that ROS will serve this role today, even though maybe certain sectors are a little bit more incumbent with traditional robotics. I think ROS is growing in many fields, even including some of those traditional areas. So I think with hardening those capabilities, there's already power of ROS today with some of those aspects that I mentioned before here, how do you certify the product, how do you ensure security, quality, and under those areas. I think that will really complement ROS to make it a very strong standardized offering that I think people will leverage in multiple sectors and domains.
Thanks, Eric, for the statement. So I think also that ROS will play a good role in standardizing the robotics sector and will help with that. Werner, do you have a comment for this discussion here?
Yes, definitely. And on the way of ROS, it already helped the standardization of the software development process also, because it was not, what I experienced in industrial realization, software development was not on that professional level as we know it from IT projects. And this community effort, standardization, the exchange about software development on a professional level is a big influence, a big benefit of the ROS activities.
Yeah, I think that's actually a good statement. So coming from, let's say, really domain-specific languages per robot vendor in the industrial market, at least, towards a common language with modern programming languages, and yeah, so also the measures to simplify or to at least hide the complexity behind these languages. I think, yeah, that's actually a very good point there. With that, I want to just turn to another question that is maybe the final question in this round for today. Which robot, so this is more personal, so which kind of what kind of robot did you always want to have? Maybe Werner, you can start answering that.
Good question. Actually, I raised up in a restaurant in my family, and I was always busy with dishwashing in this restaurant, in the kitchen. And my family is always asking for a robot doing the dishwashing. So pick and place for the dishwasher. And that would be one of my dreams, to have really a robot which can do the dishwashing on a cycle time as a human.
All right.
Also a good economic point of operation.
Sounds interesting. Yeah, so I mean, would be more time as a child to play if you have a robot like that, right?
Yes, we need lots of perception, manipulation tasks, classification.
I think it's probably quite a challenge to do something like that. I mean, also handling glasses and this kind of stuff in a slippery environment will probably be quite a hard challenge. All right, I would also ask this question to Eric directly. Eric, do you have one type of robot that you always wanted to have?
Not sure if it's exactly what I wanted to have personally, but I think personal assistants, or maybe almost like a robotic nurses, people that can take care of both take care and conduct certain tasks as well as interact with elderly, I think is one area which I think really might be very good. And so I have this kind of personal assistant at home that can help people that may need some extra hand that may be on their own, I think would really be very, very good. So I think that's my bet.
All right, thanks for that answer. And I think with that, I would thank you all, Eric and Werner, for your interesting presentations, as well as your comments in the end in this panel. And to the audience, thank you for the many questions on this session, and I hope you enjoyed it, and see you in the next session. Thank you very much, and have a nice day.